what I would like you to have out is the conductor activity. So if I'm looking at the conductor activity, what's the pattern for conductors?
Metals.
What's the pattern for insulators?
Non-metals.
Yeah, non-metals. Okay. What about the metals? There were some metals in the room that didn't seem to conduct.
But it was because the paint, or there was a coating that was a non-metal.
Okay.
Metal.
How do you know that was the case?
Because we peeled some of the paint off.
Okay. And then what happened?
And then it conducted.
It conducted. Okay, so if you're looking for patterns, metals, they're the ones that... Now, in terms of the chemistry of that situation, what's the deal with metals? Chem 2 people? What's going on with metals that allow them to be conductors? Amber?
They have a lot of electrons to sort of share.
Okay, and if I'm looking at, and I'm talking about the final shell, okay, what's the final shell going to look like? Is it going to have like maybe 1, 2 electrons, or is it going to be packed, or is it going to be like 4?
It's going to be like 4-ish.
4-ish?
In the middle.
For conductors?
Isn't it?
Well, let's see. If I have a situation and the electrons are very easily moving through there, okay, so what does that suggest about the
But
electron?
there are probably a lot of electrons to move around.
Okay, there are a lot of electrons to move around, right, in terms of just the actual number of things. But we need to, like, focus on which electrons are held tightly, right? In what type of materials are electrons held tightly? And in what type of materials are the electrons able to let these guys move from really one atom to another? They're bouncing around quite a bit. Okay? So, what are you looking at there, John?
Well, don't like most metals have basically 2 electrons in their outer shell?
Okay. Would that make sense with this idea that they're moving through all of these?
Yeah, and then it doesn't have a very high electron affinity, right?
Okay.
It doesn't need them.
Right. So if I have maybe 1 or 2 electrons in my outer shell, then, you know, I'm not holding on to those guys so much. If I have 6...
Then you want like 2 more to complete that outer shell.
That's right. Okay.
But they don't have any reason to like collect them and hold on to them.
Correct. Does that make sense?
Yeah.
Okay, good. Okay, so we're talking about some, you know, this is all tied together. We've got, in terms of conductor and insulator, where have you heard those terms before? Insulation, okay. What does insulation do? It keeps the heat in. What's another way to phrase that?
Keeps the heat out, or the cold out.
Yeah, it keeps the cold out, or it keeps the heat out in the summer, right? So what is it doing? It's keeping the heat out. It's keeping the heat in. What's it always going to be doing?
Providing a barrier.
Yes. Okay, insulation is going to be providing a barrier. It's like, hey, it's a roadblock. It's not going to let, and in that situation, what is flowing there? What do you say? What word do you use?
Heat.
Yeah, it's the heat flow. In the summer, you want the heat to not flow into your house, right? In the winter, you want the heat to stay in your house. You don't want it to flow outside of your house. So the heat flow, you want it to stop, okay? And you'll find often that good conductors of electricity and good conductors of heat are the same thing. In terms of the terminology, the vocabulary, insulation, it's doing the same thing for heat as an insulator is doing for electrons in this situation. Okay, that pretty much wraps this guy up. Now, if we go ahead and we look at the fuses, what did you find with the fuse activity? John?
The more batteries you added, the more like violent the reaction got.
Okay, if you had, if I have 1 battery in here, and then I just have, this is the thick wire. Those would be the alligator clips. Okay, and then if I have one thin wire here, if I just have one battery in this situation, did much happen? No, not too much happened. If I went ahead and I put 2 batteries in there, yeah, maybe a little smoke. Okay, these wires have oils and stuff on them, and so that it starts to smoke a little bit. And then if I put 3 batteries on there, then what's happening?
It lights up.
Yeah, it lights up. It sparks. It actually burns through. Once it burns through, what is happening to the electron flow?
Stops.
It stops. The electron flow stops. Well, let's think about that for a minute. Why would you want to have a fuse in a circuit? Okay. Sarah?
You were talking to us about car speakers. If you had car speakers there, you'd rather burn out a little fuse than your like $5,000 speakers. You rather, like, if the battery sends too much energy through the system and the speakers wouldn't be able to handle it, it blows out the fuse before it gets to the speakers. So the speakers are okay.
Okay, good. So if the speakers, let's say just talk about battery equivalents. Okay, let's say the speakers can handle 10 batteries. Okay, and if the fuse, let's say that you have in your car, you've got electrical systems, and that thing can put out a lot of electricity, right? So let's say your car can put out, let's say 20 battery equivalents. Okay? So if I'm in that situation and it's like, well, wait a second, I'm sitting there and I start turning up the stereo, and the stereo and car system, it can put out 20, right? And the speakers that are in the back, they can only handle 10. As soon as I get the volume, as I turn the volume up, I'm sending more and more energy to the speakers. What's eventually going to happen to the speakers? They're going to blow out. Okay? Well, what if I know that something's going to blow out, and I choose the item that I'm going to have blow out? If I put here a fuse in a circuit, and then I come down here and I have this situation, this is my speaker, and I have that guy hooked up. If the fuse blows out at 5, let's say, then will I ever get to the maximum that my speaker can handle? No, why not? Because the fuse blows, and when the fuse blows, what happens to the whole circuit? Yeah, it stops, okay? So fuses are used as safety devices, and in homes they actually, that's what was there. If you get a really old home, you go down in the basement, you don't have fuses, or a really old home, you don't have circuit breakers, you actually have fuses in there. Now, a disadvantage to a fuse is it actually burns out. That fuse, which is what you made, once it's burned out, it's gone. Okay? If I buy a fuse for my house, and if I plug too much stuff in at Christmas, I have a whole bunch of Christmas lights and all that kind of stuff, and then I actually blow out this thing, this fuse, I'd have to go in the basement and put a new one in.